Picture a cow standing in a field, head down, moving forward a few inches at a time, chewing grass. Now, picture your ancient ancestors. Did they spend their days doing exactly the same thing? To find the answer, we have to look back 2 to 4 million years to the African savanna. This was the era of the Australopithecines, early hominins like Paranthropus robustus, who lived long before our own genus, Homo, appeared on the landscape. Researchers studying the fossilized teeth of these ancestors used carbon isotope analysis to determine their diet. By analyzing the chemical signatures preserved in 3.5 million-year-old enamel, they made a discovery that stopped the scientific world. The teeth showed a massive presence of C4 carbon. This specific signature proves that these early hominins were securing a significant portion of their daily calories directly from savanna grasses and sedges. Grass provided a stable source of survival for these creatures. This chemical evidence places our upright walking ancestors in the exact same dietary category as modern wildebeests and cattle. They were grazing. This discovery presents a massive biological problem. The primary component of grass is cellulose, a tough plant fiber that is almost impossible for most animals to digest. Cows can handle it, possessing 4 stomach chambers specifically evolved for rumination. Humans and our primate ancestors have just one, unable to efficiently break down cellulose. For them, raw grass is a caloric dead end, passing straight through without releasing energy. This creates a paradox. The enamel provides undeniable proof that they were eating grass, but their anatomy suggests they should have starved while doing so. The solution lies in their target. Our ancestors ignored the above-ground blades, focusing instead on the underground storage organs, the corms, rhizomes, and bulbs. Unlike blades, these structures are highly digestible, providing a dense energy source a single stomach can actually process. To reach them, these hominins used their hands and simple tools to dig. They were bypassing the limitations of a grazing mouth by using the mechanical advantage of primate fingers to extract what hoofed animals could not. This was smart grazing. Our ancestors used their unique anatomy to access a massive reservoir of calories hidden right under the feet of the grazing herds. While digging for roots, they found another high-value resource, the nutrient-dense seeds at the top of the grass stems. These seeds are packed with protein and starch, but come with their own set of defenses. Raw grass seeds are encased in hard husks, and the energy inside is stored as crystalline starch, a form that human digestion cannot process efficiently in its raw state. To convert these seeds into a usable food source, ancient humans turned to technology. They used grinding stones to crush the husks and break apart the starch, effectively building the world's first food processors. Long before the first farm was ever planted, humans were already milling flour. They were using stones to transform raw grains into something edible, tens of thousands of years before they ever learned to grow them. We usually treat the shift to agriculture, 10,000 years ago, as a sudden flash of invention. In reality, it was the formalization of a foraging strategy our ancestors had been refining for millions of years. The crops that built global civilization, wheat, rice, corn, and millet, are entirely comprised of selectively bred grass seeds. We didn't choose them at random. We chose them because we had already been eating them for eons. There is an unbroken line from an ancestor digging for roots on a savanna to a modern human eating a slice of toast. The toast is just a highly processed version of the same ancient survival strategy. Human civilization succeeded by partnering with the most abundant plant family on Earth. We used millions of years of ingenuity to transform an indigestible landscape into a global food supply.